Hi, everyone. Welcome to the Physionic podcast. If you're new here, welcome to the Physionic podcast, or if you are coming back, then welcome back. Just a quick introduction. If you're not familiar with who I am, my name is Nicholas Verhoeven. I'm a PhD candidate in molecular medicine, and I do hold some nutrition science background from my nutrition courses that I took during undergrad, and hold, I suppose, my master's in exercise physiology. Not that I suppose, but I'm thinking, does that qualify in this situation? But considering we're going to be talking about muscle, it absolutely does qualify. So, as I just alluded to, this particular podcast is going to be discussing muscle, but really more so the protein content. So I'm going to be going into some decent depth, not extreme molecular depth or anything like that, like I sometimes do on Physionic, but I do want to discuss the amount of protein, kind of sort of like the optimal amount of protein for muscle growth in when you are trying to gain muscle or when you're trying to preserve muscle. I'm also going to go into the type of proteins, some of the benefits of certain ones. I'm also going to go into the timing of protein, as well as I'm going to go into how protein interacts with other nutrients like fat and carbohydrates. And then I'm also going to go into how protein habits need to change based off of your age as well as your sex. So we'll be talking a little bit, not a whole lot, on the differences between men and women. It's just kind of a supplementary information. But the base part of this is going to be really just looking and telling you specific, I guess, recommendations that you can go off of that are sound in science, in that they're actually based off of a scientific review that I'll have linked for you. I've been following one of the researchers for quite a while, and he does a lot of protein related, nutrition related, but more specifically protein related research. And I've really enjoyed a lot of his work. So he came out with a review maybe like 2 years ago, 3 years ago, something like that, from when this podcast is recorded, and kind of put together at least a lot of the studies on nutrition timing and all that stuff. So that's where all this information is going to be coming from, as well as some that I've kind of picked up from my own reading as well, from other studies, which of course I've got content on the channel. But with that, I'm going to go ahead and kind of go into our bit of an introduction, and then I'm going to go into some of the specifics on exactly how we should look at all this stuff. Okay, so first off, one question that people probably should be asking, what we should be asking ourselves is why? Why do we have to consume protein? I realize that a lot of people say to build muscle, right? But let's go a little deeper than that. Like, why actually do we need to build muscle? If we accrue muscle, right, we put on muscle, and that's made up of proteins, right? You know that much as well. And why not just keep that protein and just be done with it? You're done. You're an adult. You've grown. Good to go. Don't need any more protein. Well, the reason for that is because just like any biological process, really, honestly, any process, except for maybe if you're talking about maybe physics, if you're talking about atomic structure or something along those lines. But even then, I think in physics, there are also, this is beyond my scope of knowledge because I'm not a physicist, but even in physics, from what little I understand, is that there is still a degradation that occurs. And with a biological process, which is my area of interest, there's definitely a degradation process, and that happens with musculature. That happens with protein in general. So not just musculature, proteins that make up your neurons, proteins that make up your eyeballs, that make up your ears, that make up your skin, everything, literally everything, bones, everything. So you have these molecular insults that occur to that structure. So that structure ends up breaking apart. So functional proteins that served a function, they were swimming around the cell, and they did the thing that they were supposed to be doing, and they continue to do the thing they're supposed to be doing, like For example, like creatine kinase, let's just take a specific example. Creatine kinase is an enzyme, which is a protein, and it has a particular structure to it, and it interacts with creatine, and it interacts with a phosphate molecule, and then eventually creates creatine phosphate or phosphocreatine. So that's its function. That's what it does. However, eventually, through radiation, through mutations, it can. There's a variety of different things that can happen. That protein gets damaged. The molecular structure, the bonds that make up the molecular structure of that protein get shifted in some way or get destroyed. And then that leads to from a functional protein to a non-functional protein. Now, obviously, the cell can't, no, it's not good, right? You can't have non-functional proteins because then you just accrue a bunch of non-functional proteins and then, well, you don't live much longer. So the cell has obviously robust systems to deal with those proteins. And there are two major ones. One of them is really a hot button one, and I actually study both of them in the lab. One of them is the autophagy system, right? So you go in and you end up destroying large swaths of protein that are non-functional, or you might get rid of organelles like mitochondria, which are made up of a ton of different proteins. Or on a more, on a smaller scale, you can destroy individual proteins through what's called the proteasome. So for that reason, that degradation process that continuously has to happen, you're losing proteins all the time. Even though they were functional at one point, once they're non-functional, the cell has to get rid of them. So that's the reason why we have to continuously be consuming protein every single day. And while the protein requirements for a person who doesn't exercise and doesn't want to build muscle is actually quite low, the RDA is extremely low. You could probably get away with like 80 grams, probably less than that. I don't know exactly the number, but it's really, really low. And you would have to really try not to hit that protein target. However, if you are trying to build muscle, if you're trying to go from a basal state of non-exercising to exercising and then trying to accrue muscle and become bigger and stronger, man or woman, then you need to be consuming excess amounts of protein because there are certain benefits to that. So let me throw up a graphic. If you're, as usual, if you're just listening to the podcast, don't worry. I'll be describing all this stuff like I usually am. But with these protein sources that we're getting, if that's from animal-based or if that's from plant-based, ultimately they're made up of the same parts. They're made up of amino acids. So those amino acids are then used to create new proteins within the cells. So the proteins from a food source get broken down into the constituent parts, the amino acids. Those circle through the bloodstream, and then those enter the muscle cell in this situation. And then the cell then restitches all those amino acids together into the protein that it needs. Now, for that degradation side, well, let me, address the protein synthesis side. That's the one that we're going to be most focused on, is the actual production of more proteins, more of these functional proteins. So these amino acids, like I said, get stitched together into what's called a polypeptide chain. So it's literally just a chain of amino acids, and then you have other proteins that come around and they essentially twist it and turn it into the functional protein that we want. Now, that's protein synthesis. So now you form this protein that you can accrue inside the muscle, and eventually it starts to push the muscle cell membrane outwards as the muscle starts to grow. So that's one side of the equation. On the other side, like I described earlier, you have autophagy and you have the proteasome. And in my graphic here, if you're watching, I have the proteasome. And both of those actually function relatively similarly in how the proteins are tagged. They're tagged through ubiquitin tags that are attached to those functional, well, at this point, probably non-functional proteins. And then that goes through proteasome and gets degraded back into its constituent parts, back to its amino acid parts. And some of it gets recycled, and some of it gets exported back out of the cell, and we end up excreting it. So protein sources, so from animals or from plants, end up exciting or increasing protein synthesis. So they increase the production of new proteins within the cell, and they tend to put the brake or slow down that degradation process. And the reason for that is through molecular means like AMP kinase and mTOR. I'm not going to go into all the molecular mechanisms for the time being, but the point being that once you eat protein, you're increasing muscle protein synthesis, and we're going to look at some data. I'm going to be explaining some of the data on how to exactly do that. What's the best way to do that? And then, of course, on the flip side, it also tends to reduce degradation quite a bit. So that's kind of a long-winded way of saying why we actually need to be consuming protein. Now, on top of that, of course, you have to be exercising. So something that you might be thinking as well. In that case, then I'll just eat protein. I'll eat more protein. Maybe instead of 80 grams, I'll consume 160 grams, and then I'll have double the stimulation for muscle growth. However, doesn't work that way, because you actually have to target what cells are going to be taking up the protein. And if your body doesn't need the protein, if there's no sink for the protein to go into particular cells, then the body ends up just oxidizing it, using it for energy, and or ends up just disposing of it because it just doesn't need it. Usually it goes through oxidation, so it gets used in metabolism, and then it doesn't actually get used for production of things. It gets used for the production of energy. So that's where exercise comes in, because you lift weights or you run or whatever it might be, but obviously more specifically for muscle growth, you need to be lifting weights. Then that tells all those cells suddenly have this massive stimulus of, wow, we need a lot of that building block. So protein, once it goes through the circulature, once it goes through the blood vessels, and it just passes by those cells just gobble up a ton of it, and then that ends up stimulating muscle protein synthesis, not just protein synthesis for the entire body, but muscle protein synthesis. So protein consumption excites protein synthesis, and not only that, exercise does as well, and exercise also targets that protein synthesis. So that's kind of the introduction that I want to offer, but like I said, I'm going to go into the amount of protein, the type, and the timing of consumption, because all of those play a factor, among others, like if you pair that with carbohydrates or if you pair that with fats, for example. So I've got my outline here. I was initially going to do it in a particular order, but I think what I'm going to start out is kind of go big picture, go with total protein. So the total protein, again, this is all based off of this scientific review, which I'll have linked for you, but the total protein is set between 1.6 and 2.4 grams per kilogram. If you are, and the reason for that range, and there's usually a range I should finish that statement, 1.6 to 2.4 grams per kilogram of body weight. Excuse me. And the reason why I had to finish that sentence is because some people were probably going in their head thinking, well, wait, is it but lean body mass or is it body weight? So it is body weight. However, of course, there's going to be caveats that if you are, I don't know, let's say if you weigh 500 pounds, then obviously you're going to want to have to use a different metric. You probably can just cut that in half. Probably have to make other adjustments. But for the average person or a person that's really fit, then just sticking to that recommendation, 1.6 to 2.4 grams per kilogram. And of course, as you go through different studies, they're going to have different recommendations based off of the different measures that they used. But it's been shown to be effective for maintaining maximal muscle mass. And that is specific to calorie deficits. So 1.6 to 2.4 grams per kilogram of body weight is for pretty severe calorie deficits too, about 40% deficit. So because a calorie deficit inherently actually reduces muscle protein synthesis. So if you have less energy around, those master regulator molecules that I briefly mentioned, like AMPK and mTOR, they tend to be less active. So consuming more protein actually stimulates them from a different direction. Instead of cellular energy stimulating them to produce greater cells, to produce production, to have muscle protein synthesis, you're stimulating them from the amino acids, because both of those can have an effect on like mTOR, for example. So to mitigate this reduction in muscle protein synthesis from consuming so few calories, a much less amount of energy from your food consumption, then you consume more protein as a result. However, when you're not in a calorie deficit, they've also done studies on that. And actually, which was really cool, I thought this was really cool. They did the exact same on the exact same individuals that were in the calorie deficit. They just repeated the study. So there's like no variability, which is absolutely awesome, that you can compare. So if you were to compare two different groups, two different samples of two different people, let's say, then you'd be introducing potential error. However, because you're doing it to one group and then you're saying, okay, well, we're going to give you some time off, and then when you come back to the lab, we're going to do this experiment again, but we're changing a few variables, then the variability is all within that same person. So it makes for a great study. It has its disadvantages as well, but ultimately it's great. So anyway, so when you're not in a calorie deficit, when you're not in an energy deficit, when you are actually trying to facilitate, when you're increasing your energy as well as increasing your protein, then you've got a double whammy there. Then you're maximizing muscle protein synthesis. So those same individuals consumed 0.8 grams per kilogram to 1.6 grams per kilogram and experience greater increases in muscle protein synthesis. So there's a benefit. You can obviously lower the amount of protein that you consume, and I'll touch on why exactly in just a second. But to on that high end for the calorie deficit, remember it was 1.6 to 2.4. And they tested the 2.4 grams per kilogram of body weight in this condition as well, and they found that there was no additional benefit. So massively over-consuming protein does not lead to a greater benefit. We're going to assume these individuals are natural, as in they're not taking performance-enhancing substances. So 0.8 to 1.6 grams per kilogram of body weight. Now, why, if you've got an increase in energy intake and you've got an increase in protein, why wouldn't you just think, well, let me just keep increasing? Because there's a threshold. Once you hit that threshold, there's nothing that's going to push it past that threshold. So 1.6 seems to be, at least based off of what they studied, seems to be the maximal amount. That's the high amount. And you can't, even if you go above that to 2.4, for example, you don't see an added benefit from that. So you'd be wasting your money, wasting your time, wasting your effort. And you're going to be really full too if you consume 2.4 grams of protein per kilogram. Okay, so that's the total amount, right? I covered in a calorie deficit. I considered in a maintenance, and also with a slight surplus. Those were the 0.8 and 1.6, somewhere within that range. Oh, and I guess I should mention one thing. The reason why you might want to go with a little bit higher, like 1.6 as opposed to 0.8, because that's a pretty steep range. That's a huge range, actually, is if you're lean, if you're really lean, and you probably already know this at this point, but if you're really lean, then you want to be on that higher end of that protein, because you are really driving your body into the state where it's starting to catabolize more and more muscle. Is it still going to be extreme? No, it's not. As long as you're exercising consistently and you're pushing yourself and you're consuming high protein. But if you're just starting out, for example, then you could consume less. You could definitely be consuming less. Okay, so that is the total amount of protein. I'm going to touch on the type of protein, and I'm going to show you a little bit of data on that, as well as the amount of protein per meal, and then I'm going to touch on, just briefly on the timing of the protein, okay? So the type of protein is, from previous information, that came from a variety of other studies that have looked at animal-based proteins. They found that animal-based proteins are the best type of protein that you can consume in terms of efficiency. The least amount of protein consumed gives you the most muscle protein synthesis. Okay, that's how I'm thinking about it. That's how I'm describing it. So I guess I'll just wrap this up into one with the amount per meal. So what they did was they measured egg protein, and they measured whey protein, and they measured a bunch of other animal-based proteins, and they found that about 20 grams of protein per meal would get near maximum muscle protein synthesis. So let me put it this way. The best bang for your buck is 20 grams per meal. Obviously, if you're consuming 200 grams of protein a day, you can't limit it to 20 grams of protein. You're going to have to go way above that, 40, 50 grams of protein or 60 grams of protein to make up, to get that full 200 grams. So, but I'm just saying the minimum to get the best bang for your buck is 20 grams. Not too bad. Not too bad at all. And that would be from an animal-based protein. I will cover plant-based in just a second. Now, let me show a graphic here of some of the data here. So they used 20 grams, and then they wanted to know, okay, well, what if we double that? And if they double it, so if you consume 40 grams of protein, you see, and this is kind of variable across a variety of different proteins, that if you consume 20 grams or if you consume 40 grams, the 40 grams only gives you about 10 to 20% boost, according to a variety of different studies. So can you be consuming 40 grams? Yes, absolutely. And will you see a benefit? Yes, absolutely. But the benefit, like you're going from 0 to 20, you're getting 80 to 90% of the muscle protein synthesis benefit, and then doubling that, which is a huge increase in protein, only garners an additional 10 to 20% of protein. So it's really up to you. I mean, but like I mentioned, if you're going to be consuming 200 grams, let's just say you're set at 200 grams of protein, yeah, you're probably going to be consuming 40 grams per meal anyway. So in that situation, you are going to be getting that benefit of the additional 10 to 20%. Okay, so that's all based off of animal-based proteins, however. So they also wanted to compare to plant-based proteins. And with plant-based proteins, they're considered far less efficient. Remember that my definition for efficient is based off of the amount of protein to maximize muscle protein synthesis, or get the best bang for your buck. And they found that 35 grams of plant-based proteins from they tested a variety of different ones. 35 grams showed no increase in muscle protein synthesis. So remember, 20 grams with animal, 35 grams with plant-based. With the animal, you saw almost a complete rise in muscle protein synthesis. With plants, you see nada. So then they were like, okay, well, let's just keep upping it. Let's keep increasing it. And so they went all the way up to 60 grams per meal, and they found that, yes, that had an effect. So that increased muscle protein synthesis. Now, the reasons for that are pretty numerous. One, lower digestibility. So really old content. We're going way back here. I have some videos and some articles on fiber and the solubility and the viscosity. That's a fun word to say. Viscosity of fiber can trap particular macromolecules, macronutrients like protein, to the point where they actually don't allow for their absorption. So higher fiber foods it depends on the type of fiber as well. It's more on a gradation, so it's based on a scale. It's not like you have soluble and insoluble, even though that's kind of how it's talked about. But in reality, like all the different types of fibers, they kind of mix and match. They're kind of on a gradation, but I digress. The point is that with plant-based, you have less digestibility. So that's one thing. Another thing is lower amino acids, and specifically to essential amino acids. And you've probably heard of branched chain amino acids. Those are important, not in supplementation. I can do other content on that as well, but supplementation of branched chain amino acids seems to be relatively useless if you're just going to be consuming that. But the idea behind those is that those particular amino acids are essential amino acids, and so essential that they themselves are the most potent in stimulating protein synthesis. The three are leucine, isoleucine, and valine. But leucine specifically is the one that really creates a robust protein synthetic effect. So plant-based proteins tend to have, actually almost universally tend to have lower of amounts of these essential amino acids. So even though the amino acid profile as a whole may be pretty good, they have lower levels of those trigger amino acids, and therefore you need a lot more of the total plant protein to be able to get a comparable amount. So that's why it's less efficient. I could just hear the vegan screams. and the third reason is due to lower splanchnic extraction. So what does that mean? The amino acids are not deposited in the blood. So when you eat particular proteins, particular amino acids, they find themselves in the intestines, right, in the duodenum, the ileum, the jejunum, and then they will cross the intestinal barrier. So you've got a bunch of cells, intestinal cells there, and they have all these different protein. I don't want to say the word protein too much. They are made of proteins, but we'll just call them channels, gateways. There you go. And those gateways allow amino acids into the intestinal cells or past the intestinal cells, and then they're kicked out into the bloodstream. So then they've gone from the outside world into the inside world of your actual bloodstream. So you can have lowered levels of that from the plant-based proteins. And some of that is because it gets trapped, so it doesn't actually get allowed into the intestinal cells, or also it can be disposed. So it's never actually deposited into the bloodstream. You just end up excreting it. And probably a lot of that has to do with fiber as well. So, and obviously there's other benefits of plants that are maybe not that great for muscle growth or getting those amino acids into the bloodstream, because they can inhibit. In particular, well, actually, you know what? I'm gonna save that. I'm gonna save that for in just a little bit. Okay, so I talked about animal proteins, I talked about plant proteins, and you can partially mitigate the plant protein problem by just consuming, let's say, 3 different plant proteins together in one meal. And then the different profiles, overall amino acid profiles, the 20 amino acids, but specifically the essential ones, those can kind of make up for one another throughout the different plant. You're still probably going to have to eat more of the plant proteins regardless, because the animal-based proteins are you're literally consuming like muscle. So you know that it's got the amino acids that you need because you're going from muscle to muscle, as opposed with plant, there's no muscle there. So yeah, the amino acid profile is going to be less than desirable. Okay, but another thing about animal-based proteins is that the rapidity, the speed by which we consume or that we digest and absorb these amino acids as well. So, for example, like whey protein, right, is the gold standard protein, and the reason for that. One of the reasons for that is extremely high leucine levels, which I mentioned is that essential amino acid that triggers muscle protein synthesis robustly the most. And not only that, it's also rapidly absorbed. So, you got a lot of the gym bros that are just like, well, I got to pound my shake, 20, I don't know why I changed my voice for that, but just roll with it. 20 to 30 minutes after their workout, the post-workout window, which has been largely debunked. But, just for the sake of kind of the traditionalist attitude of bodybuilding, consume whey protein because it spikes your amino acid levels really quickly, goes into your intestines and flies through your intestinal cells and gets thrown into the bloodstream really quickly. So here you can consume the 20 grams. However, we are not awake 24 hours a day. So it's important, and I actually have content on this specifically as well, that we also, maybe it's not important, but I'll say it's important, but it's not critical, put it that way. It's important that if you really want to maximize things, you'll want to consume a protein before you sleep as well. Now, there are two ways to go about this, two primary ways to go about this. One of them is to consume something like casein protein. So casein protein is a much slower absorbing protein. So it's not nearly as fast as whey protein, but that actually gives it an advantage that whey protein does not receive. So whey protein will spike in the bloodstream and then pretty rapidly go back down. However, with casein, it very steadily goes up and it kind of stays up, but it never really reaches that peak that whey does. So people kind of discount it at times. However, if you want to get a more robust muscle protein synthetic response from casein protein, although it is animal-based protein, you actually have to double the amount of casein protein to get a comparable or relatively similar muscle protein synthetic response. So that means that you would need to consume 40 grams of casein as opposed to the 20 grams of whey. And that will slowly get digested, slowly get absorbed throughout the night. So that's an added benefit. Now I'm probably not going to go into the muscle full effect, but that is something that may be of consideration as well. If you're interested in me discussing that sometime, then I can certainly do that. But I have content on that as well if you'd like to look that up. Okay, so we talked about the type of protein. We've talked about the amount of protein. We've talked about the amount per meal. And now let me just quick touch on timing. And then I'm going to go into how carbohydrates and fats affect these effects, or these muscle protein synthetic effects, and then aging and a little bit on differences between men and women. And then one weird trick. I should have opened with that because I've got one weird trick that I'm sure nobody else has ever discussed. I am serious about that. So the next thing, timing of protein. So typically you'd want to consume, and this is where the intermittent fasting people might scream, is typically you want to consume you want to be consuming your 20 grams minimum protein, animal-based. Let's just assume it's animal-based. 20 grams minimal every 3 hours. So that will continue to increase your muscle protein synthetic effect. Now, I guess I'll quick touch on the muscle full effect. The problem is some people think, well, let me just inject protein into my body, or let me just keep cramming protein every, I'll consume 30 grams of protein, 40 grams of protein every hour on the hour, and just continue to do that. And I just remembered I forgot to say something about the sleep thing. I'll come back to that. But yeah, so the idea being that you just continuously increase your amino acid levels. However, research shows that you can't do that. If you consume protein every 2 to 3 hours, you're doing great. That's the best way to go about it because you're constantly stimulating muscle protein synthesis. However, there's a limit to the number of times you can do that. So if you just constantly have your amino acid levels high, ultimately your cells actually shut down. They shut muscle protein synthesis down regardless of the fact that there's plenty of amino acids around. So in a way, you can kind of breathe a sigh of relief that you don't have to be constantly eating protein. But, just stick to about every 3 hours, be consuming 20 to 40 grams of protein. Again, if we're talking about animal-based. Okay, now, before I forget again, I mentioned that there are 2 ways that you can go about sleep. This is really disjointed, but there are 2 ways to go with the protein consumption. You can go with casein, consuming, let's say, 40 grams, or you can consume an animal-based actual solid protein, not a whey protein, but an actual solid protein that takes a long time for your body to digest. And it's also going to slow down digestion because when you're sleeping, you're not digesting very well. So obviously, if you've got stomach issues, then you should probably stick to something like a casein protein. But if you are an individual that's got an iron stomach, like I don't have issues whatsoever, I could eat like 4,000 calories and then just like pass out, then it's perfectly fine instead of investing in casein that you, let's say, eat some like 20 grams of chicken or protein wise of chicken, something along those lines. And that will also have kind of an extended benefit. Okay, so I'm glad I touched on that because I would have been mad at myself if I'd forgotten that. Okay, so now what I've coined the bi-nutrient effect. What happens when you consume carbohydrates? What happens when you consume fats? So in mixed meals where you're consuming carbohydrates with proteins, it tends to change the absorption of the protein. Now, of course, granted, I've already talked about plant-based, so we're talking carbohydrates there. And it's not just the nutrients themselves. It's actually just the carbohydrates themselves. So carbohydrates slow the digestion. And you can play that to your benefit as well. So if you slow the digestion, then from sleep, for example, that would be a great opportunity. So consuming carbohydrates, and of course you're going to be consuming low GI or consuming high glycemic index carbohydrates. Of course, glycemic index just goes right out the window the moment you start consuming with other substances like protein. But still, the point is that, of course, the type of carbohydrate that you consume is, of course, going to change that overall idea. But if you consume any carbohydrate with a protein, it will slow digestion. So that's something to consider. And of course, the type of carbohydrate, especially if it's more veggie-based, if it's more fibrous, then it's going to change the absorption of that protein as well. So carbohydrates affect digestion and absorption in that way. However, fat consumption does not seem to have any sort of negative impact on protein absorption unless it's high amounts. So if you're going to McDonald's and eating a Big Mac, and it has like 40 grams of protein and you're consuming 30 grams or 40 grams of fat and 30 grams of protein, then that might be a problem. So if you're consuming large amounts of fat with that protein, it can also inhibit the absorption of that protein. But it's less of an issue. Okay, so then something that I teased earlier, you didn't realize I teased it, but I stopped myself, micronutrients. So talking about vitamins and minerals also seems to help with protein synthesis. I don't have the data with me, but it's in that scientific review. They show some graphs as well where consuming micronutrients, just talking about your plain old vitamins and minerals that you would get out of just your general consumption of food, that can actually improve your protein synthesis. However, unless it's consumed in a concentrated form. If it's in a pill form, think of like I consume a half of a multivitamin almost every day. So consuming it in a concentrated form is actually detrimental to protein synthesis. Do I think that is a long-standing effect? Probably not. It's probably just in that instance, in that window of maybe like an hour or two or something like that it can have an effect. So concentrated levels of vitamins seem to impede the ability for the cells to absorb protein. And again, you have a lot of these interactions between these macromolecules and micromolecules, interacting with the cells, and the cell can only take up so much. So it has to deal with all of that. And that's probably one of the reasons, as well as like certain micronutrients can interact with other micronutrients and cause them not to get absorbed. So that's actually something that not a whole lot of people talk about, but certain micronutrients can actually impede. So let's say if you're consuming, I know this is a bit off, but like somewhat related, vitamin E, and then you consume vitamin C. I don't remember exactly what it was. Maybe it was like D and iron or something along those lines. Those can interact to the point where you're not actually absorbing any of the, I think it's like vitamin D or something like that, doesn't get absorbed. So, things like that. Don't quote me on those exact micronutrients. I need to look into, need to remind myself. But there's definitely interactions where you actually don't end up absorbing, even though you consumed it, you're actually not taking it because it's so concentrated with other micronutrients. So that's one detriment of a multivitamin. Okay. All right. So I've covered all of that. Okay, let's talk a little bit about some. So at this point in the podcast, if you want to stop listening, feel free. It's already pretty long, but you can stop listening at this point. And I now am going to go into some supplementary information on aging. So if you're interested in aging, stick around. Men and women, stick around for that. Or the one trick. Okay, so the supplementary information, just talking a little bit about aging. Muscle protein synthesis itself does not reduce with aging, which is kind of surprising and kind of cool too, because we actually have a robust ability to maintain and build muscle for a very long time, many decades, into your 50s without any supplementation, no like testosterone, nothing. If you just exercise and recover, then you can build a physique that is equivalent to like a 20-year-old. However, of course, the caveats to that are exercise related, like, can you recover? And like, did you break your back? Things like that. But ultimately, our ability to maintain muscle and to kind of reach our peak physique is not inhibited by age for a long time. And one of the reasons for that is because muscle protein synthesis itself does not decrease. However, there's a caveat to that. The amount of protein to consume to maximize muscle protein synthesis. Remember, it was around 40 grams, 20 to 40 grams before. Now it actually needs to be even more for you to maximize muscle protein synthesis. So as a total for people who are older, I'll give you a number exactly in just a little bit, you need to be consuming more total amount of protein, and per meal you need to be consuming more protein. So that is about 1.5 to 2 times the normal amount. So if you calculate it out, let's say 1.4 grams per kilogram of protein, then you would need to do like 50% more than that, or double that. If that worked for you when you were 40, right around, and this is an arbitrary number that I came up with, but right around age like 60 and above, you'll want to increase your protein rather substantially. And you can usually tell this if you're not recovering anymore as well from your workouts, for example, and your sleep is the exact same, and carbohydrates and all that stuff is the same, then you can focus on your proteins. So, and this is due to a phenomenon known as anabolic resistance, where you can still reach that maximal level. It just takes a lot more protein to reach it. Okay, so that's my tidbit on aging, and you'll probably, obviously per meal, you'll want to increase the amount that you consume as well. So probably around like 50, 60 grams of protein per meal. So it's a lot of consumption, and for sure you're going to be cutting down on those carbohydrates and fats as a result. Okay, so men and women obviously have different amounts of muscle. I just blew your mind there, I'm sure, with more upper body muscle for men, and actually women are really strong in their lower body specifically. But men tend to have a lot more muscle in their upper body. So, but like I mentioned, that both sexes actually can maintain their muscle mass for a really long time. However, and the actual amount of protein consumed is roughly the same between the sexes, at least based off of the information that I know so far. And I'll certainly be updating that as I delve more into that literature. However, there is a distinction in that as you get older, men can stick to what I just mentioned. However, women can actually benefit from a bit more protein per meal specifically due to reduced protein synthesis ability that comes from aging. So especially around premenopause and menopause and postmenopause, that's really when you want to target consuming just a little bit added protein. So if for men, let's say men consume 40 grams, 50 grams, something like that, you'd want to consume maybe like 60 grams, just a little bit more to maximize that protein synthesis, because the maximization of protein synthesis does decrease for women just a little bit, and for men it seems to stay pretty consistent, as long as you're regulating the amount of protein per meal. Okay, so the final thing that I wanted to touch on is the weird secret. I ran across this again in that scientific review, so be sure to check it out. I'm not just making this stuff because I'm going to sell you a product. But it is possible with high-fat diets that can blunt muscle protein synthesis. I kind of alluded to it earlier on a meal basis, but consuming high fat can blunt muscle protein synthesis. Yet, when you underconsume protein, let's say you're traveling and you can't get your hands on all the protein that you need. Let's say you need 150 grams of protein total, and you need to be consuming 30 grams of protein, something like that. Per meal or something, but you can only get, let's say 20 grams or 15, let's say 10, 15 grams, something that's really much lower than what we were talking about per meal. Apparently, omega-3 fatty acids seem to maximize protein synthesis. Who knew? I didn't know that. That was something that I learned. So this effect is not present, however, when amino acids are saturated. So if you're thinking then, oh, well, I'll just take omega-3 fatty acids to supplement on top of my already perfect nutrition, that does not work for muscle protein synthesis. It might work for other things, health reasons, but not for MPS. And the reason why, I don't know, because I just kind of read it briefly, but I can certainly look into it as well. But ultimately, if you're under-consuming your protein, you're going to be under-consuming your protein, supplementing that, like going to the store and just grabbing some like fish oil or krill oil or something along those lines, and getting those omega-3 fatty acids will bump your muscle protein synthesis ability. I imagine that has something to do with some sort of cell signaling, that omega-3 fatty acids seem to have an effect on mTOR or something along those lines. It's also possible, and I am really pulling this out of my but some mTOR independent muscle protein synthesis can also occur through particular acids. So there was this one acid that, of course, I'm blanking on the name on, even though I've covered this multiple times. It's produced by an enzyme called PLD, phospholipase D, as well as a few other enzymes as well. But ultimately, this particular molecule, this acid, gets produced, and it's made out of fats, or one part is made out of phosphatidylcholine. Nope. Is that right? Yes. It's made out of phosphatidic acid. There we go. All right, so phosphatidylcholine is cleaved, so this particular molecule, which is partly made up of a fat. So I wonder if maybe the omega-3 fatty acids allow for the production of more of this phosphatidic acid, which then allows for the greater stimulation of muscle protein synthesis independent of the amino acids. Now, of course, you still have to have amino acids present, but maybe the cells become more efficient in some way. Or maybe it just increases muscle protein synthesis and the studies just haven't picked it up, and then it just plummets again because you can't actually produce any proteins without the amino acids that you need. But there's a tidbit, there's some information. If you are under consuming your protein, you can consume some omega-3 fatty acids. That will help out. If you are hitting your normal amounts of protein, it's not going to help you. It's not going to give you an added boost. Again, there's that ceiling. There's that threshold. Once you hit it, you can't go beyond it unless maybe you're taking some sort of performance-enhancing drugs. Okay, wow. I've been talking for like 45 minutes beyond. So let me just wrap this up. Conclusions, takeaways. Hopefully you got a ton of takeaways out of this because there's a lot here. And certainly I'll be going into this in far more detail in future content. And I've covered isolated pieces with previous content as well with a lot more studies. Okay, so conclusions and takeaways. Consuming at least 20 grams of protein reaps most of the muscle protein synthesis potential, with doubling that amount only contributing a small amount more benefit, so about 10 to 20% benefit, added benefit. Animal-based proteins are more potent than plant-based, although consuming double or triple the amount of plant-based proteins can also increase that muscle protein synthesis ability. So it's not like you can't do it on plant-based. You absolutely can. You just have to consume a lot more. However, mixing the plant proteins is a better alternative than just jacking up your total protein consumption. So if you have the option, if you're vegan, right? Let's say, and you want to consume, you want to maximize your muscle growth, instead of focusing on, well, let me just double my total amount of protein, what you'll want to do is maybe focus in on the types of plants that you're consuming or plant-based proteins that you're consuming and mixing those rather than necessarily just doubling, let's say, your overall protein content. So that's something to keep in mind. Consuming either casein before sleep or eating a whole protein, so an actual solid protein, with a mixed meal containing carbohydrates is beneficial for slow release of protein into the blood as amino acids into the blood, and that will then increase muscle protein synthesis overnight. But if you go casein, you'll need to double the protein that's consumed. Remember, 20 to 40, so you'll want to consume around 40 grams. You should consume around 1.6 grams per kilogram of weight if you're gaining or losing body fat. So I just kind of picked that middle target. But if you're leaner and you're losing weight, you're going to probably want to go a little bit higher than that. And well, I just wrote slightly more if you're losing. More will not help if you are gaining. So if you're gaining weight, if you're in a caloric surplus, an energy surplus, eating 2.4 or more than 1.6 or a lot more than 1.6 will not give you an added benefit. You're wasting your money, you're wasting your time, and you're wasting your flatulence. So if you're around age 60 or so, you should be consuming 50 to 100% more protein per meal to maximize protein synthesis. And women, as you age, you may want to consume slightly more since your muscle protein synthesis reduces slightly with age. And finally, if you're under consuming protein, the weird trick, eating omega-3s seems to increase muscle protein synthesis. Now, a lot of this is based on muscle protein synthesis. I just want to quick throw it in here. It doesn't necessarily translate to muscle growth. You have to take into account a lot of other things as well, but it certainly is a great indication. Okay, folks, that's what I've got for you. That was much longer than my usual. I've been kind of sticking to 20 and 30 minutes, but occasionally you just kind of have to stretch your legs. So thanks for stopping by. Thanks for listening. And hopefully this was really informative for you. And if you have any questions or anything, just please reach out and I will catch you in the next one. Have a good one. Bye.